Hi friends, this is Shashwat Chaturvedi and we are going to discuss functions part 2 as I told in the previous chapter. Now we are going to see from the functions definition. You can read about me from this part, and we are going to discuss about function with default arguments, and this will be the complete chapter. So function with default arguments, we should know when should we use the functions with functions that are overloaded or function with default arguments. While using overloaded functions, one should be clear that it has to be in programming where the same types of operations has to be performed for different argument values. So while using the overloaded functions, we should have a clarity in our mind that what functions we are using or what functions are being overloaded in the program, and we should know as well how are they being used and what are the different values or different arguments given for a particular function. We should know it very well, and that should be clear in the programmer's mind. This was a very necessary thing we should know about. A function returning value. When a function completes its execution, it can return a single value to the calling program and containing answer to the function as solved. So for example, we just solved any problem, and we have to return it to the question. Now we can return the answer only. We need not return the whole variable and the whole process that we have completed or we have went through. So that is not must, and we can just return one value, and that is quoted here, that we can return single value to the calling program or the program that is called. Moving ahead, recursive functions. This is a very important part and you should know about it in functions. It is a function that contains a function call to itself. For example, my name is Shashwat and I'll call myself that like, hey Shashwat, and I have some addressing myself is recursive, and that is recursive function here. What it means, this is in layman's language, and we can connect it very well. So it is a function that contains a function call to itself, or a function that rather calling another function calls itself for next sequence of execution. So I have to execute a problem, so that's why I'm calling myself. So that is quoted here, for the next sequence of execution we need the problem needs to call itself, or the function needs to call itself. There are two important points that should always be considered while defining recursive functions. Each time a function calls itself, it must be nearer in sense to the solution of the problem. The very first must thing is that the problem should be getting solved, and it should not create a mess and not create a loop in itself, and so that we don't get a solution. Instead, the solution should be getting in one call itself, and there must be a termination condition for stopping the terminating or stopping or terminating the recursion. As I said, there should be no loop, and that is a must, and that is what is said here, what this says here, that it should terminate at some point after first call. And this is what recursive functions are. Inline functions, as the name suggests, there is something that is given in line, and how do we know that functions are being used? So inline functions, you could simply repeat the necessary code in your program, inserting the same group of statements whenever it is needed. Now we don't need to give any statement or any function again and again. We can use the inline function property and make it repeat, or we can repeat it again and again wherever it is necessary in the code. Fine. Lifetime and scope variables. When the function sum will be called, memory to the local variable will be allocated by the function in program stack. As soon as the function execution will be over and control get transferred back to the compiler, memory allocated to the variable will be released and will be available for further use. So as this line says that when the function sum is called, or when the variable or any data is called, the memory local variable should be active at that very point. Sometimes if we are working in some other memory section, that the system is not able to switch over very easily, and that creates an error in the code. So for that, the lifetime or is used, and that it should be active throughout, and execution should go well, and control gets transferred back to the compiler. Memory allocated to the variable will be released and will be available for further use. So when the variable gets away, and it can be used again, so the memory allocation or in the compiler gets transferred back. Region of source code over which the definition of an identifier is visible, it is called as the scope of the identifier. So in the region of source code, that is the programming commands we are giving, the definition of identifiers is given, so that is called as the scope of identifier. Similarly, where we are declaring the variable, it is called as the scope of variables. Global and local variables. Local variables are defined as those variables whose lifetime and scope is limited to the function in which it is defined. So when any variable that is limited to a single function, it is called as a local variable, whereas any variable that is used in all the functions repeatedly, or is uniformly being used throughout the program for different functions, are called as global variables. So that is discussed over here. The global variables are those whose lifetime and scope is not limited to any function but are defined throughout the execution of program. Moving ahead, storage class of variables. The compiler allocates and deallocates memory location during the complete cycle of program execution depending upon the nature of variable. So the compiler is the one to give memory allocation to any address or any variable or any data, any given data, a particular address and location during the complete cycle of the program, like writing the program, runtime and compile time is called as combined are called as complete cycle. So depending upon the nature of variable, we know this as we have discussed it earlier as well. And storage class govern the lifetime, linkage and treatments of the objects and variables. So as I told you, all of this is given in a memory. So that is given here, that it governs the lifetime, linkage and treatments of this object and variables. And based on scope and lifetime of variable, the memory allocation scheme to the variable can be defined as auto variable and external variable. External variable is a short form for external variable. So we'll see it in detail. That was all for the external and automation variables. That is not necessary for function definitions as well. Thank you, and don't forget to rate, review and recommend my video, and tell it to your friends as well. Thank you.